So, like I said, you've only got like one more thing in derivatives to learn called slope fields. So we're just using our derivatives knowledge from here on out. Okay, we're just sketching graphs today and Tuesday. We're using derivatives to complete that task. Okay, so can I determine with the first derivative, what can I determine of a function? Okay, slope at a point, correct? Okay, I'll put that there. What? Okay, critical values or points. What does that lead me to? Extreme values.
Sign analysis.
Yeah.
Concavity.
So I can find min and max there from the first derivative, right, Damon?
Right.
What else can the first derivative tell me? If the derivative is positive, the function is increasing, right? So we can do increasing and decreasing. We're not being contextual right now. We are just mathematical. So yeah, we could do velocity and all that stuff. We're just talking straight up calculation math. Okay. So that's the derivative and what it can give us, right? So increasing or decreasing, we can do min or max. We can do the slope at a point. Tangent lines, all that stuff, right? Okay, so you have learned it, maybe not have it mastered yet, but we've learned it. Okay, what about the second derivative?
Points of inflection.
Yeah, we can calculate points of inflection.
Concavity.
Which would be somewhere right there between where a concavity changes. And we can determine concavity. So that's where our focus is going to be today and Tuesday. Okay, is using that to sketch a graph. All right. Let's start easy. What's our old standby? Okay, don't answer. That's our old standby. We're going to sketch that. I know you know what it looks like. It's going to help us.
And the derivative is just a linear line.
Okay, so what's the derivative? Yeah.
2x.
Now we're going to, so using the derivative, calculate increasing and decreasing min-max values. So what do I need to do with this? Set equal to 0. And what does that tell me? That x equals? 0. Okay. How do I calculate a min or a max, local min or max? Because it's no interval, right? So local min or max.
You plug in 0 to the original function.
No, that would be an absolute min or max calculation.
Average rate of change. So that's
We know too many things that we can't make a difference.
Sign analysis
Oh.
gives us local min or max. Or increasing and decreasing behavior with, we're using a sign analysis for this. Okay. Yeah, there's a lot in your heads right now. but you'll learn to compartmentalize it. And it becomes easier.
We're going insane. We'll find out what's happening.
Yeah. Okay, sign analysis is always with the derivative or second derivative, but we're working with the derivative, so that's what we're going to use. What do we got? Okay, so local min, remember, negative to positive, minimum. And this means the function is increasing or decreasing? Decreasing and increasing. So we know it's going to probably look something like that, right?
Wait, I thought the derivative for x squared was just a linear line.
The derivative is linear.
It's parabola.
I'm drawing the original.
Oh.
This, so when you're analyzing a function using derivatives, it's giving you information about the original function. All right, so everything we do is obtaining information about the original function. All right, second derivative is?
So were we supposed to know what the original equation was?
You have to.
I'm so confused.
Why?
Like,
I gave you the original,
yeah.
and we just calculated where that original is increasing, decreasing, and has a minimum using the derivative.
So we're trying to draw the original, not the derivative.
Yeah. Okay.
But you plug it into the derivative,
Plug what in?
S prime. Minus
I just don't understand your question. You said plug it into F prime. I don't know what you're talking about. Yes. When you do a sign analysis, determine the derivative. When we do a sign analysis with the derivative, we always plug into the derivative.
Okay.
If I were doing the second derivative, sign analysis for concavity, I would plug into the second derivative. Right? So sign analysis always goes with the level that you're working at. All right. Can this equal 0?
No.
It's always positive, right? So F is concave up for all x values, right? Does that make sense with what we know of x squared? So we're going to sketch F.
If it was -2, would it be concave down, even though it's a straight line?
What it?
The F double prime. If it was -2,
If F double prime is -2,
yeah, would it be concave down?
concave down. This would be different too. Okay, using the information up here, we have a critical point at x equals 0. That's where our horizontal tangent line is, right? We know that we are decreasing here, correct? And we know that on this side we are increasing. And this is a minimum. So and what do we know about concavity? Yeah, we're concave up for all x values, right? So our sketch is going to look something like this. You have to match all those things. And you can sketch your graph. So that's a basic example of using derivatives to sketch a graph. Okay. Try one that's a little more difficult. Shall we? We're going to sketch that graph.
Oh,
Yay! Using derivatives.
Yeah.
Do we only go to the second derivative for these? Yeah.
It's very rare that we head past the second derivative.
Is there any like application of the derivative, finding out the like behavior of the original graph?
Yeah. We just don't tackle that in Calc 1.
Do we calculate or tackle it next year?
Not even then.
When do you tackle
When you need it for your career as an engineer. When you're a rocket scientist, literally. What's the derivative here? Somebody individually.
it? Huh?
Just use expert.
don't necessarily be talking to the desk.
Where
I'm sorry. Yeah, should be X. X nice.
Set equal to?
Zero.
We can factor that.
Oh, you.
Right? So what are my x's?
2 and -1.
Okay, so those are my critical values, or critical points. Now I do what?
Fine analysis.
Analysis. Okay. Okay. What value am I going to pick? What am I going to put here?
-2.
Just -2?
Anything on the left of it that's within the
F prime at -2, thank you. F prime at -2 is?
No, it's -1. Oh wait, no, it's
Say
0.
negative times a negative, which is a positive. Okay, choose a value in there. Thank you for making it easy.
It's still negative.
And,
1.
okay, and that is?
Positive.
So both of those are.
So it's increasing, decreasing,
Do we have a local max?
Increasing as, okay,
We have a local max at -1 and a local min at 2.
so the graph is starting to look something like this, right?
We got it.
You can have a local minimum that's more, like, the y value is greater than the local max.
The y value? We don't have any y values.
No,
over
no, no,
there.
so like 2.
Two, those are x values. So at this point, if you wish, you can start to sketch out your graph. Okay. We know these are critical points, right? And our graph is going to do something like this. But we don't know much more than that, right? So -1 and 2. So any guesses as to Concavity?
Concave down,
Yeah, that's a good
concave up.
guess. Concave up's probably a good guess, right? Where's the point of inflection?
0 or 1.
Okay, somewhere in here, right? Let's figure that out. How do you figure out points of inflection?
Second derivative of prime
Which is?
minus 1.
Is that a point of inflection?
You got to do another side?
The answer is yes. Have you justified it yet?
No.
No. Okay. So this is where our sign analysis, we're in the second derivative. We use the second derivative. Pick. Thank you for making it easy.
We choose 3,220.
You're, never
Basically, you
mind.
do
I'm
not
gonna,
speak for us.
all right, so yeah, point of inflection, concave down, concave up, right?
Yeah, that's what I was thinking.
Round.
Whoa, yes.
That's like really, like, clean cycle.
So 1/2.
You see it? Counting cycle? Cycle.
Get out. Because he doesn't like us.
Okay.
That's a lie.
Yeah, you're right.
Can I place this graph with the y-intercept?
The original equation equals 0?
Those would be x-intercepts. We don't have to mess with that. What's the y-intercept? It's right there.
Zero?
Oh.
Basic math.
Yep. Remember that, pre-calculus, thank you very much. So our y-intercept is right there. All right, so now we can kind of sketch our graph. We are concave up here. There's our minimum, right? Here's our maximum. That's what we look like, okay?
Is that right? I thought maybe.
Wait. Can you give us, define where the critical point, like the y values of the critical point?
We didn't.
Well, then how did we not?
I don't.
No.
I did not place these with a y value. You can, if you want to plug those critical points into the original function, you can place them correctly.
Because you just sketched it.
I did not. Right. It's the constant. So, yeah. So if you're looking at a quadratic, the y-intercept is the constant. The y-intercept is the constant. So this is the one we're sketching. That's pretty much how we handle sketching graphs. I could show you a trig function.
Okay.
Thank you.
Yeah.
Okay, do we have to do one in the homework?
Yes.
Then yes. I don't want more information than I need.
What's that?
That was Hunter deciding between open.
It's very jailed it.
I'm losing it slowly.
You think you haven't already lost it?
Slowly.
We're such a positive class. Keep telling stories.
Oh, yeah, definitely.
Yes, we dissed each other, so it can end up on the internet like it is now.
Oh yeah, it is on the internet.
I forgot.
I forget this happened. I felt like.
No,
We're
not
just so
teacher
comfortable
does.
with the internet, it's just like, oh yeah,
No,
we good.
No.
I mean, it's really helpful, but it's just like you don't.
It takes a little extra work on my, not a big deal.
Have you seen
Okay,
some people do
so we want to sketch.
Yeah.
We can sketch that graph
It's get sketchy.
with zeta pi.
I want to know what accent that is. Kind of looks scratchy.
Yeah.
I- All right, so let's see, Mr. Schubert. What's the derivative?
I too would enjoy passing.
You're not the quarterback, you don't get to do that.
Ooh.
I know what it is.
Negative sin x plus 1.
See, if you would have passed, you would have
Really fast.
passed on an opportunity to show how smart you are.
Sure she had a mini heart attack when you heard his name.
Yeah, probably.
Okay,
Because in homework math.
Lindsay, what do I do with that information? Is that equal to?
Yeah.
Okay,
Figuring it out.
solve that equation. First one that gets it right gets a Danish.
How old are these Danishes?
Just a few weeks.
60 degrees, which is
That's still positive.
yeah.
And
No, but it's negative
radians.
sign equals a
And
negative.
radians, you monster.
So the
You're a
negative
monster.
is- Oh, so it is 60 degrees.
It's not 60 degrees because we're in radians.
Yeah. No, oh my God, you're a turd.
I'm not a turd.
Oh, I'm gonna throw my.
5 or 3.
Thank you, David.
That's ridiculous. I had it.
I said 3 times in radians, and you just conveniently ignored me.
But I don't know radians. I know degrees.
Well, convert it.
I forget how to do
That's
it.
negative.
No, I didn't.
Divided by 1/8.
I have the negatives.
It cancels.
Oh.
They cancel out. So x is, oh man, you guys didn't get it right.
Pi over 3 times. So pi over 2 3.
Sine x is root 3 over 2. That power of 3.
I was wondering.
Oh, yeah,
so
'cause
it's
you guys
pi
have
over
a
4.
tangent.
Oh no, it's
Nobody gets it.
Nope.
I tricked you on bamboozle.
So Montana's right.
30 degrees. Power of 6.
Wait, why is it 30 degrees? Because that's where the sign from that.
Yeah.
I don't want to drink that.
Lead is good. For making stuff.
It's also good for killing brain cells.
Yeah.
So stealing.
Valid point.
I remember much smarter.
Nerve cells, actually, in general.
Even worse.
Okay, sign analysis, right? So I'm going to choose 0 and pi over 2 is easier, but pi over 4 would work.
You probably would be closer, yeah.
No, because it's 0 or 1.
Yeah.
What's that little symbol inside the
What symbol?
The 0 inside.
F prime at 0. So if I plug 0 in, one positive, 1/2. If I plug pi over 2 in,
Negative. Yeah.
negative 1 plus 1/2 is negative. So again, we have increasing, max, decreasing, right? All right, power 6. And we know in here, here. Okay. All right. Cheyenne. Are you all done writing? Okay, what's second derivative?
Oh, sorry. Yeah, because the math murder.
Half of the concept.
Math murder is a fucking thing.
Okay.
Yeah.
Can't go back to still fun, it's on the board.
And so what do I do with that information? You betcha.
When in doubt, set it equal zero.
Zero.
It'd be at 0 and
No, it's not.
Wrong again.
pi over 2.
Eh.
Pi over 2
So
and
0 and 2 pi.
No.
Yeah, 0 and 2 pi.
No, it's not. It's pi over 270 divided by 180 is not 2. It's cosine comma sine.
Why'd
It's
you
pi
get rid
over
of the
2.
negative? Hey, stop your guessing. Why'd you get rid of the negative? Math murder.
So you can divide by -1 and it.
Okay, just making sure
Right.
that wasn't like some trickery. some
No.
trickery.
I'm a math teacher, I don't engage in that stuff.
270 degrees and 90 degrees.
Which is
2 pi over 2. And 2 pi, wait, 3 pi over 2.
3 pi over 2 is not in our interval,
So we don't include it. I told you it was pi over 2.
so we don't worry about it.
I never saw the interval.
How about, no, I told you those, and we're like, congratulations, for changing your.
You're just so kind to each other. Okay, then we do a sign analysis, right?
You know that's not how this works.
Kindness week's over.
Yeah.
All right, then have at it.
You should have seen, if you think today's back, you should have seen kindergarten about yesterday. Her saltiness level was reached in state.
Sorry, you told me to be stupid. It was-
Okay, so cosine of pi over 4, whoa, positive.
But is that negative?
Oh, sorry, negative cosine.
Oh, it's just a
Yep.
whole. Yeah. No.
So negative cosine of pi over 4 is negative.
Oh, I see it now.
3 pi over 4.
You can't multiply by 180, that's just
What's cosine of 3 pi over 4?
Great question.
It's negative. Times the negative is a
Positive.
positive.
Oh, because it's negative.
I'm gonna draw the unit circle on the 80
You can do that.
Sketch the graph on it.
That means we have concave down, concave down. Point of inflection at pi
So
over 2.
it only has one focal point.
Yep. So you have a point of inflection here.
Pi over 2.
And then pi,
We do this number with the max. What happens over here?
It starts going up.
It's concave up, right?
Yes.
Do we ever reach a critical value? No, so something like that.
why did we only get the one value for our point?
Yeah, that's what I'm wondering, because this should be symmetric.
Do we need to factor?
Sine is 1/2 at pi over 6 and 5 pi over 6. Thank you very much. We got so caught up in Danishes, we neglected one of the critical values.
Look what you said.
My, oh my. That'll mess you up. So, red. There we go. Okay.
Just.
All right. Again, using derivatives. Using derivatives. Get those processes down. If you look at again, look at this. That's chapter 4. And And we add some contextual stuff with position, velocity, acceleration. But that's pretty much chapter 4 right there. You can do that, right? Chapter 3 is just calculating those items. So it's not that much material. You can get it. You can do this, man. Okay? The hardest part is interpreting what they want from you. Honestly.
I watched the show through the Untouchables. There's some of us like part of it.
Wow. You are now educated a little bit.
It's good. I
It's a good show. I'd put it in my top 10.
In your what show?
What?
What show?
Function Redemption. Like, I hadn't even
Okay, slight bit due Tuesday. If you wish, you can start the spiraling because it is the weekend. Here's the rest of what we're going to do Tuesday. Oh, my hand's starting to cramp.
I don't know a lot of spiraling.
This is not due until Wednesday. Okay, so, but if you want to start the spiraling, you can.
I get that.
Thank
So
you.
the bottom part is okay.
Okay, so the spiraling is all due Wednesday, but the actual lesson is due Tuesday.
So today's work is here. This will be Tuesday 4.6b. I'll show you a couple more with examples with asymptotes, and then the spiraling. But you can start spiraling first. All right. Thanks. We're going to get this. I know you're